Hello everyone, we are back. My name is Marcos and I'm here to bring you Go with examples. And today we are going to take a look on range, functions, and a lot of different details on functions as well, using variadic functions, multiple returns, anonymous functions, and closures. Let's go. So just as usual, before we start, just a quick reminder that the content we are taking a look here is from a website called gobyexample.com, which there is a GitHub repository available that you can clone and has a lot of helpful examples that help you to learn Go. And that's the content I've been using to make those videos. It's outstanding content. Please take a look on their website and also on the repository. Give it a star. And yeah, let's just take a look. So today we're going to take a look at a few different syntaxes here. We'll start with range. If you programmed in previous languages before, this is range is just an additional syntax on the top of for on the loops. You might have known this as for each on a few other languages such as C#. And yeah, so this it fits well because we already learned arrays, maps, and slices. So this is definitely a syntax that we need to understand in order to make our codes, better. So yeah, let's just start here. As usual, once again, we will take a look on the latest version of the repository. So just do a git pull here. I have everything ready to go. Just gonna do a clear. The folder, I am already on the range folder, so that's great. So what we're gonna do now is let's just run it, right? There are a lot of things here we're gonna walk through. Let's run the code first. So go run and dot, which is running the local Go program, and we have some output in here. I just keep this on the side. This time I put my terminal on the right side of the screen just for readability and space. Yeah, so let's start here. So at the beginning, the very first example, the very first print, what we have is a slice of integers, and there are 3 values, and what we do is finally using the range syntax. So the difference between before is we have a predefined values first, and then you assign them, and the syntax is you add range and what is the object you want to iterate through. The output of this one is it's just the sum of all the values inside of here, which is equal 9. You can see here on the right side. And I wanna pay attention a little bit more on those variables right here. So first, we already mentioned this on the previous video. If you have not watched the previous video, please take a look. There is a playlist that will be available on the link below on the description. So yeah, so this first one here means it is a blank identifier. So it basically say, hey, there is a variable here that I don't care. I don't need to store it. I don't need to use it. So just discard. And then the second value is the actual value here. So the range syntax, the way it works is the first return is an index. It is the where within your array or slice, what's the index that it's currently iterated through. And the second one is the actual value. It is interesting that you have just those 2 combinations right away. It makes it easier when you're coding. So in this particular case, we are using a blank identifier because we don't care, once again, and that's it prints the value. So when you go down here, you'll see that it's actually using it. It actually mentions here, so a range on arrays and slices provide both the index and the value, which I just mentioned, and it also mentions that it's using a blank identifier on the previous example. But in this case, there might be useful examples that you need the index, and there are indeed. So this example here is just using the index, and in case it finds a number 3 within that slice, it would just print the index of number 3, which in this case is the index is 1, because it's 0, 1, and 2. So that makes sense. There is no other value within that array that contains the number 3. So that's just one output. Just moving on here, just a follow up from our previous video, we are using a range within a map. right? So in this case, we are declaring here a variable called KeyVS that is a type of a map. The key of that map is a string. The values on those maps is also a string. So you can see here that we are pre-assigning those values right away. So the first key will be A, the first value is apple, the second key is B, the second value is banana. And same thing, the syntax here, it shows the first variable on this using the range syntax is going to be the keys, and the second value is going to be the values itself. K and V stands for key and value respectively, and we are just printing those two values right here. There are two elements on this map. That's why we are printing A as apple and B as banana. Makes sense. Definitely using ranges, you know, when you're working with maps makes total sense. So just moving on, this is an interesting thing. It says you can have just one variable out of that range, and that will be the key, because you know, always return the key first and the value second. It's like having a blank identifier in second, but it makes no sense because it's just like the afterwards, right? So what it's doing is just, you know, printing out the keys. The keys we have here is A and B. But let's just say if I use the blank identifier here like this, and I saved it and I run it again, the code, instead of printing the keys, we're going to print the actual values, right? So it's just a quick way to tell you, like, hey, if you need just the first value, which is either the index or in this case the key, you don't need to use the second variable. Yeah, that makes sense so far. And the last but not least, we're going to take a look here on a different concept in Go, that the way it treats strings is a complex subject by itself. It sounds simple, but each language, they manage, you know, variables such as strings like quite differently under the hoods. But in any case, in this case here is actually explaining how. So range on strings iterates over the Unicode code points. The first values is it is the starting byte index of the rune. Don't worry about this terminology for now. There is actually an example on the Go by Examples website that we're going to take a look on the runes itself and what actually it means. And that's why it says here, see strings and runes for more details. That will be the next video, so please stick around. And yeah, so what's the output here? So there is a first variable here, which is an integer. So the second variable is a rune, and then we are printing both of them at the same time. So in this case, the string is Go, so there will be two values for the letter G, which is respectively 0 and 103, and the second value for the letter O, which is 1 and 111. And again, don't worry about it, what's the actually meaning of this for now. We're going to take a look on the next video, but it just, because it's presenting the syntax range, is just wanted to let you know that Go accepts using range within a string, and we're going to work a little bit more with this later on. And with that said, that's pretty much everything for range. Let's take a look next on functions. So we're going to take a look here on functions. So first thing I usually like to do is just clean the terminal. We have brand new examples. I have functions open right here. I'm going to close here range just for the sake of visibility here. And then functions. Yeah, so we have been using functions, you know, in a few other examples, I think. But it just methods, right? So functions and methods are terminologies that, you know, very similar, if not the same. So it's just the way this file is going to explain to us how we use functions and how we can declare them, and, like, you know, some shortcuts and everything. So yeah, let's just take a look. Actually, before that, let's run it, right? So right side, let's change the terminal, cd ... The folder name is going to be functions. Here we go. We are on functions. Let me clear the terminal, and we're gonna run. Go run dot. Here we go. So we have only two outputs out of this program. We're gonna understand what it actually means while we go through this. And then the first output is 1 plus 2 equals 3. The second output is 1 plus 2 plus 3 is equals 6. So what do we have here? So we have first of all, we have a function called plus. this function accepts two integers. Very simple. You specify a variable and a type, a comma, variable and type, and so on and so forth. And here, that's the important introduction here in Go, is you can specify what this function or method. In Go, we use the terminology more functions for some reason, but yeah. So it's just returning an integer, this particular function, and just one line of code here, it just return a plus b, and that's pretty much it. The second example that we have here is it's just a shortcut in terms of declaration. So you do a variable a, b, and c, and you just specify integer on the very last variable. That is a shortcut to say, hey, all the preceding variables that is declared on that function, it's also integer, very simple. And then this particular function returns an integer, and then we open the curly brackets, and then we do the actual code. In this case, is return a, b, and c. So we have two function declarations, which is likely being called for this. So let's just continue. So in order to call the function, you just specify the function name, open parentheses, and specify the parameters. In this case here, this function does return an integer, the plus function. So which is the first one we saw here at the top. So what we do here, we declare a function called res, which stands for as a result. And then you do a colon equal sign because you're declaring that function right now. Pay attention to that distinction, that this not function. This variable does not exist up to this point, so we are declaring it. That's the syntax right here. And then we say, hey, take the result out of this function, and we know that it's going to result 3. So we output here 1 plus 2 equals 3. Which is the result, and we can see it right here. And the second one, look at this, it's using the equal sign. So because the res variable already exists at this point, so if you do a colon here, it will just say, hey, this variable already exists. You cannot just declare it multiple times. So yeah, so you call the second function, which is called plus plus. And then you pass 3 parameters, and then you just output of those 3 parameters, and this case is equal 6. This file is very straightforward. That is, as you can see, is more like, putting the details of the syntax itself, and then you can put the returns, and then a quick shortcut on how to declare the variable types within the arguments. And that's pretty much it for functions. The other 3 files is also related to functions, just a little different details. So the next one, we're going to take a look on multiple return name values for functions. Let's go. Let's take a look on the multiple return name values here. I'm going to close this, open the file. As usual, we're going to go up one folder, and then let's take a look here on this folder, multiple return values. That's great. And then let me just expand it. The name here is slightly larger. Here we go. That's good. Yeah, so let's run it, right? So go run. Oh, the terminal got a little bug there. Go run. Oh, I think it's because I put a dash at the beginning. Here we go. So let's just run. There are 3 outputs so far. So there is a 3, a 7, and a 7. And let's see what's the proposal here. The proposal is actually very simple. It's just to tell you that you can return multiple values within a function, and this is used a lot here in Go. Other languages, up to a few years back, we kind of recommended to not do this. Instead, you could just return one object, and that object could have as many properties as you want. The equivalent in Go would be a struct. However, it is very useful to return multiple values because you might, for readability for once, and also like you could also return errors. And this is like you also always return the standard value and an error variable. And this value and error is used a lot in Go, so you gotta realize that. So it's better for us to learn and get used to the idea. And even when you are developing applications in Go, it's also expected that you always return an error variable. There's no concept of exceptions or other things. I know I'm jumping too much up ahead right now. There will be examples more like on the error handling aspects of Go, but I'm just to let you know that having multiple returns on a function is useful when it comes to that kind of design pattern, or like just say standard, using in Go. Anyway, So yeah, so the returns here is 377. Let's take a look here. So the first function, we have a function called vals. There is no parameter on that function and returns 2 integers, right? So the syntax is you gotta open parentheses and then you specify the types. You notice here that you don't specify the names, just the types. Whoever is consuming that function will declare a name to return it. And then the return is just a comma separated value. So because you're returning 2 integers, you just say return first value, comma, second value. And yeah, let's just take a look here. So the way it goes is you declare, in this case, if you want to retrieve, right? If you want to retrieve the values from that function, you just declare, in this case, A and B, because it's returning 2 values, and the colon equal sign because those variables are not, pre-declared, and we just print both of them, A and B, right here. Same thing, just, in case you want to use the blank identifier, let's just say you don't care about the first return, you only care about the second return. In this case, it's declaring variable C. Then we're going to print that value here. Therefore, we only have 1. Once again, this is used a lot with errors. Ideally, you would not ignore errors because you should always check if there's an error being returned. You're going to treat it accordingly. But yeah, that's pretty much for multiple return values in Go. Let's take a look next, which is variadic functions. Variadic functions, let's go. So we're going to first of all, as usual, close this Go, and then variadic functions is open. I'm going to go one folder up, and then variadic, nope, here we go. And clear this. We have a clear file. Before we navigate on what's going on here, let's just do a, oh, not a dash, go.run. Here we go. Go run, space, and dot. So there are a few outputs here. Let's just understand the outputs before we go through this file. So we have likely a array or a slice with 2 values within that array or slice, 1 and 2. And then there is a third number called 3. We'll understand that in a second. And they're pretty much similar values for the following ones, which is 1, 2, and 3. And here's 6, and this one right here. Let's take a look first of what actually means, right? So variadic functions, this is the first time I see the terminology, and here is the Wikipedia definition of what it is. The idea of variadic functions is just so that you can call many variable arguments, right? So for example, here we have a function called sum, and there is a variable called nums, right? So nums is a argument that you're accepting. When you mouse over here, it already identifies that as a slice of integers. Why? Because that's the way the Go is structured, first of all. But the syntax wise is there is a 3 dots and an integer, right? Let's take a look here on how this is actually working. Look at this. The way we call that function is specify, hey, 1 or 2, but there could be any number of arguments, right? That's the beauty of it. So inside the function is treated as a slice, but the caller that is calling that function, you can specify multiple comma separated values. And that's very handy for, readability and a few other things. And also make it easier, because in this case, if you accepted a slice, what does, stop you from just actually accepting just the slice and then making the caller make a slice in order to call that function? So it also make it easier to program, right? Let me just undo this stuff here. Okay, so 1 and 2, right? So we call this function 1 and 2. So what we're gonna do here first, there's a print on nums. Yes, so the print is 1 and 2, right? So those are the 2 values we have here, and then there's a total. Oh, I see. So like what you're gonna do is you're gonna iterate through that nums, and then you're gonna specify the total amount within that slice. That's the number 3 right here. So that makes sense. So it does the same thing next. You specify, hey, 1, 2, and 3 as arguments on that function, and then the sum inside of that is 6, and it prints first the slice and then the sum. So that makes sense. And the last but not least, you can also call, and this is like, you know, the beauty of the flexibility here in Go is, let's just say in this case, if you do have a slice of integers, why not just pass the slice instead of, you know, having individual variables, which it would make a lot of effort to do that. Instead, the syntax wise that it works is if you have a slice, in this case, a slice is called nums as well. So what you do, the syntax is just pass the 3 dots afterwards, and this is going to convert, you know, this slice into a variadic function parameter, and which is also happens to be a slice here. But syntax wise, it's very easy to call it, right? And I can tell you right away, this is used a lot, especially on the Golang itself, like, you know, the functions and the framework that Golang provides. There are like several that use this kind of syntax, you know, in unit testing and some other things. And I also notice in real enterprise applications that we use this syntax. So yeah, that's very useful. And that is Variadic Functions. Next, we're going to take a look on function closures and anonymous functions, which is like related topics. And yeah, let's go. So yeah, we are going to take a look at anonymous functions and closures. As usual, we're going to close here this little file here. We're going to go folder 1 up, and then closures, not closing closures. Here we go. We cleared this. Let's just run it first, right? Go run dot. And let's see the values that we have here. We have 1, 2, 3, and 1. We'll understand what it actually means. Top to bottom first, right? So Go supports anonymous functions, and then there is a link on the Wikipedia of what it is. And then there is closures. Here is the definition of closures. Anonymous functions is something that is, you know, a lot of developers and engineers, they are already aware. You just declare you can like return a function, and you can execute a function dynamically. That's kind of the way that anonymous function works. But the closure, to me, it was a new definition when I started studying Golang. But let's take a look of what actually it means, right, in practice. So here, what we are doing is there is a function called int sec, which, you know, like sequence. And this function, it returns a function, right? Like we already saw the return syntax. Right after you declare the function, you have the type right after. And the type of return of this particular case is func with no parameters, which also returns a integer, right? So let's take a look here how this works. So we have this int sec function here, and there is a I declaration right at the top, which preassigns the I as 0. And then we're returning an anonymous function. And this is like this, every time you see return func and there is like a nameless function with like no name, and it's just like, you know, anonymous functions. That's the name. And in this case here, what it says is, hey, we have a return func integer, and then it is, you just do I++. So the very first time you call this, you know, anonymous function, it's going to be the value 1, right? Because the value was pre-assigned here. And that's what they call closures. The idea of closures is the scope of that variable, it is able to access, like, you know, 1 up, or like whatever is the scope that is predefined. So in other words, even though this function is starting right here on line 16, it is still able to access a variable that was declared outside of that, because of the closures is the way that, you know, Golang make those variables visible. Let's take a look here, right? So here we declare a integer called next int, and is a declaration, and then you just call that int sec. We're not printing anything inside, right? So the very first time you do this, you just, if you mouse over, you're gonna see that next int is a function. It was never called, you just called a function that create that anonymous function. So right now, next int is a variable that is a function, right? You can call that. So in the line 32, we're going to do consecutively 3 times just calling that function. And look at this. it's a variable, right? So you just because it's a function, in order to call it, you just pass a parameter, and this particular function has no argument, so you just open and close parentheses, and we call it 3 times. And you can see here that is 1, 2, and 3, and because it is the same variable. That's the scope of closures, right? So this function next int is able to have in memory what is the current value of I, which was declared right here on the closure side. So every time you call it, you're just going to reuse the previous value that is currently in memory. That's why you're able to increment. And this is very useful. This is like, there is a lot of applicabilities here. So keep that in mind. I would make sure, just a quick advice outside of Golang, just, by experience, be careful when you're doing this, right? So when you're leveraging closure and you're using variables that is outside of that, it might make a little bit confusing on a readability standpoint. Obviously, and the maintainability as well. So like it will be harder to maintain. Depends on how many variables you're using inside. If you're using too many variables and the way you're handling them, it might make your code, with like some code smells, and you're going to increase the cost, the maintainability costs. So be careful with that. But other than that, is still a very useful, and there's a few applicabilities of this. The next example that I want to tell you here is if you declare a new one. So in this case, we are calling, once again, there is a new int, which is a new variable, and that variable holds a function, right? And when you call it again, it has a new space in memory. So it's no longer overlapping with a pre-existing int sec, or in this case, the next int. And in order to prove this, it just printed once again the value, and you have it right here. Right, number 1. So if you keep calling it, it will just increase that number, but they are separate variables in memory right now. So that is anonymous functions and closures at the same time. So anonymous functions, you can just declare functions and return, and the idea of closures is the scope. I think for this particular example, would be nice for us to do some debugging. So let's take a look on the debugging next. So for debugging, so the first thing we're going to do here, I'm just going to close the terminal right here, just for us to have a little bit more space. So I can open the debug section right here. So what I'm going to do is I'm going to put a breakpoint right here and then hit F5. Let's just wait a little bit, Golang to open. It's just because I'm using this software to OBS to record this video, and it does consume a lot of memory. My computer is not that slow. My computer is quite fast. It's just this software is consuming a lot of memory, but yeah, just bear with me for a second. Here we go. Nice. So let me put this here below. All right, so in terms of debugging wise, VS Code standard, you have here on the left side locals, watch, the cow stack, and some predefined breakpoints. We have the hello world from the first video. I'm gonna remove that breakpoint right here. All right, so let's take a look at what it does, right? So we're gonna call the function int sec, which returns a function. Let's go inside with F10, and then you assign this here, right? So we have the variable I on the left side. You can see that it's 0, and just returns that function, right? So if you do an F10, you're not gonna go inside because you're not executing it. So you do F10 again, you have this function right here. I'm not calling just by mousing over, but when you mouse over, you see it's a function. So what I'm gonna do now, I'm gonna go inside of that variable, which is a function, right? So I'm gonna do it on F11 here, and it finally goes inside, is a function that returns an integer, and we see I, it's able to see I, right? Like the variable that was right outside. So we do I++, and you see here on the left side that I changed the value and returns I right here. You do F10, we no longer have in scope the I, but you can see here below that the debug console that outputs the number 1. We're gonna go inside once again. we don't have the letter, the variable I yet because we're not inside of the function, but as soon as I press F10, we are now inside of the function, and you can see that it's able to retrieve data space in memory that pre-assigned the value as 1. So the value is right here as 1. So you do this, it returns I, and as soon as I hit F10, it will print that value, which is 2, right? And I'm just gonna hit F10 here. We know that the next one will be value 3. And then the second one is we have a new variable that holds that anonymous function that has closures. And as soon as I do an F11 here, you're gonna see that go inside first. We have the letter variable I, which is now 0. So again, debugging wise, this is you know, easier to see when you're debugging, but yeah, just keep in mind that you be careful when you're using it. Make sure that your code is readable, regardless of your programming languages that you're using for your enterprise application. We do code at the end of the day for humans, in a sense that, you know, they are the ones that are going to be maintaining the code. Obviously, there are other ways to make code more effective, but, you know, readability is important. So, you know, just be careful when you're using that. That's everything for today, guys. Thank you very much, you know, for your time. I really appreciate it. If you like the content, please like and subscribe, and see you next time. Thank you.